For a discussion on parallel programming, I would like to go over the following problem. So we are being asked to write a function called integer count matches that finds and counts all the matches that it encounters in a linked list that match the target string. We can assume that the target string is available in the global scope. We are being asked to write a pseudocode in a C-like style. The key point here is to utilize the functional style programming using map, filter, and reduce. It's given that we have a helper function that identifies whether two strings match each other. So to begin with, since we do need to go ahead and count all the duplicates, all the matches that we are able to locate in the linked list, first thing that we would need to do is to find a way to transform that Boolean return of a helper function into integers. Since we can't count Booleans, we're going to need ones that would represent a true for a match and zeros that would represent false for not a match. It's a pretty easy function. We're just gonna take an input for a string, and then within the function we're going to compare it to our target. As I mentioned, since our target string is available in the global scope, we don't have to pass it in as a parameter. So what we're going to do next is we're going to apply a map to our linked list. In this particular example, let's say we have a linked list of 4 elements. And those elements contain strings AAA, BBB, CCC, and AAA. Let's assume that our target string is AAA. So what we're going to do is we're going to need to count how many matching strings allocated in the linked list. Clearly, by looking at it just by inspection, we can say right away that the answer should be 2. So we're going to use a map, and as a reference here down below, you can see that a map function takes a linked list. It maps a function of some sort to each element and then returns a linked list of modified data. So when we map our helper function and apply it to our first element, compare AAA to AAA, helper function will return 1. We're going to continue down the list and repeat the same action. So when we apply the helper function to BBB, that is going to return 0 because it's not a match to the target. Same for CCC, that would return a 0. And for the final element, we were going to return 1. Since the map function has a return of linked list, it will return a linked list of zeros and ones, where each one corresponds to a match and a 0 corresponds to a non-match. So now all we have to do is sum up all the ones, and that will give us the count of matching elements. Intuitively, you're probably already guessing that we're going to use reduce to apply the addition to a list. So in this particular case, the reduce is going to do its work on the output of the map. So the linked list of zeros and ones that we obtained by applying map to our original linked list data. Reduce is going to run through our list and reduce it by applying addition. In this case, we're choosing to apply addition to the list elements. So starting from the beginning of the list, we're going to take 1, we're going to apply addition to the next element, which will return 1, and then the remaining part of the list remains intact. We're essentially just doing rinse and repeat here. We're going down the list and we're reducing the first two elements. So once again, we're going to take 1, and then the next element is 0, and reduce it down to 1, and keep the remaining part of the list as is. And finally, on the last step, we're going to reduce 1 by applying addition to 1 and 1, and in the end, we're going to get 2. That's the result of our operation. So with the linked list that we were given, in order to calculate the count of matching strings, matching in terms of being a match to a target, we mapped our helper function to a data, which was a linked list data, and then we reduced that resulting list using an addition as the first parameter to reduce, and then the output of a map function is the linked list that became a second parameter to a reduce function.